You have exactly 2 minutes to talk about today is string algorithm. So we talked about graph algorithms just now, and then the next set of techniques we're going to talk about is algorithms on strings. Okay. Now, strings provide the primary means by which we interface to computers, right? So all our programs are written in languages where everything that we send it to that we write is actually a sequence of characters, right? So when we write programs, when we write documents, we are actually dealing with strings. So string matching is central to practically everything we do with computers. So if you are writing a compiler, then you are dealing with string processing. If you are writing a command processor, or if you're writing, if you're doing some kind of a search in a document, you're working on a string algorithm. Editors, if you're doing file versioning, well, again, you're dealing with strings. If you're doing so many things that we do. If you're trying to do, let's say, intrusion detection, or network monitoring, well, again, what you're doing is you're looking for certain patterns that appear on the network traffic, and that is, again, a string matching problem. And once again, we have talked about some problems in computational biology, and in fact, the edit distance algorithm that we talked about is already an example of a string matching algorithm, but we are not going to talk about edit distance here. We're going to talk about algorithms that are more efficient and can actually scale, right? So the edit distance algorithms are as we said, it's a quadratic time algorithm. It's not something that scales to very large amounts of data. So if Google is doing search on the internet, well, they have to process petabytes of data, and you need very efficient algorithms that operate on that volume of data, and you can't really do quadratic anything on that much data. So what we are interested primarily here are sort of linear time algorithms that can go through data much more quickly. Okay, so let's stop at this point, and we'll